Title: 6 turntable designs so precise they needed calibration charts. There was a time, not so long ago, when the act of playing music was a ritual, a mechanical ballet of microscopic precision. Before the algorithms, before the playlists, before the instant gratification, there was the turntable. And for a brief, glorious period, these machines weren't just playback devices, they were instruments of hyper-accuracy, crafted with an obsessive attention to detail that seems almost quaint today. We built them to retrieve every whisper from a vinyl groove, to banish every whisper of mechanical noise, to hold a constant speed with the tenacity of a Swiss watch. We pushed the boundaries of analog engineering, demanding such exacting performance that some of these turntables came with their own calibration charts, test records, and alignment protractors, proof sheets of their perfect rotational fidelity. It was a golden age, a quest for sonic purity that reached its zenith just as a tiny silver disc, the compact disc, arrived on the scene, promising perfection with the touch of a button. And with that arrival, the intricate dance of arm and platter, the careful balancing of forces, the meticulous tuning of springs and bearings, it all began to feel a little unnecessary. Today, we're going to journey back to that era, and explore 6 turntable designs that pushed the limits of analog playback, designs so precise they needed their own blueprints for perfection. Our journey begins, as so many audio journeys do, in Japan, with a turntable that would define an entire category, the Technics SL-1200, first unleashed upon the world in 1972. Imagine a turntable built like a tank, its cast aluminum plinth weighing a solid 27 pounds. This wasn't just heft for show, it was designed to absorb vibrations, to be utterly, implacably stable. The real magic, though, was in its direct drive motor. Unlike belt drive systems, which use a rubber band to spin the platter, the SL-1200's motor was directly integrated with the platter itself. This eliminated the subtle vibrations and speed fluctuations that belts could introduce. But Technics didn't stop there. They pioneered what they called quartz lock technology. Picture a tiny, vibrating quartz crystal, keeping time with absolute precision, constantly monitoring and adjusting the platter's rotation. The result? Zero drift. Your record spun at 33 1/3 revolutions per minute, or 45, with an unwavering constancy that was unheard of for its price point. It was so robust, so unfailingly accurate, that it became the de facto standard in broadcast studios and, famously, among disc jockeys around the world. The SL-1200 was a testament to engineered consistency, a machine built to perform flawlessly, hour after hour, year after year. It democratized high-precision playback, making professional-grade stability accessible to serious home listeners. But while Technics focused on bulletproof direct drive accuracy, across the sea, in Scotland, a very different philosophy was taking root. Enter the Linn Sondek LP12, launched just a year later in 1973. If the Technics was a battleship, the LP12 was a finely tuned racing yacht. Its design philosophy was radically different: isolation. Rather than brute force stability, Linn believed in decoupling the delicate stylus groove interface from all external vibrations. And how did they achieve this? With a suspended sub-chassis. Imagine a heavy, solid plinth, usually wood, and within that, suspended on 3 carefully tuned springs, floated another chassis, holding the motor, the platter bearing, and the tone arm. It was a marvel of mechanical engineering, isolating the playing surface from footfalls, from speaker vibrations, even from the subtle rumble of the motor itself. But here's where the LP12 earned its reputation for requiring a bit of a touch: it needed to be set up. The springs had to be individually adjusted, the suspension tuned just so, to ensure the sub-chassis bounced evenly, like a perfectly centered trampoline. A properly set up LP12 was a revelation, digging deeper into the grooves than almost any other turntable, revealing nuances and textures that were previously masked by noise. It was a turntable that demanded respect, a little finesse, and a skilled hand. Owners often spoke of their LP12s almost as living things, each with its own character, demanding periodic tuning and adjustment. This was precision through deliberate isolation, a handcrafted approach to banishing interference. Meanwhile, just south of the Scottish border, in England, a quiet revolution was brewing that valued elegant simplicity above all else. In 1974, Rega Research introduced the Planar 3. Where Linn embraced complexity to achieve isolation, Rega stripped everything back. Their philosophy was fewer parts, fewer places for problems to arise. The Rega Planar 3 was a masterclass in minimalist engineering. It featured a simple, rigid plinth, a glass platter, and a precision main bearing designed to minimize friction to an almost imperceptible degree. The bearing, a critical component in any turntable, was machined to incredibly tight tolerances, ensuring smooth, silent rotation. The tone arm, also designed and manufactured in-house by Rega, was celebrated for its rigidity and low resonance. There were no elaborate suspensions, no quartz-locked motors. Just a simple, low-vibration motor driving the platter via a single belt. The genius of the Planar 3 wasn't in its flashy features, but in its meticulous execution of fundamental principles. Every component was chosen for its sonic neutrality and mechanical integrity. It was the antithesis of the overly complex, a machine that proved that precision didn't always need an instruction manual the size of a phone book. Its success lay in its consistent, reliable performance, year after year, offering a clear, dynamic sound that belied its relatively modest price. Back in Japan, the pursuit of ultimate stability continued, embodied in engineering marvels like the Denon DP-80. This wasn't a turntable for the casual listener, this was a statement piece, a broadcast-grade instrument from the 1970s. The DP-80 was an uncompromised direct-drive beast. Its platter alone was a work of art, a massive, 7-kilogram, or 16-pound, die-cast aluminum behemoth, dynamically balanced for perfect rotation. This immense mass acted as a flywheel, providing incredible rotational inertia and further smoothing out any microscopic speed fluctuations. Denon's servo-controlled direct-drive motor was at the heart of it, monitoring platter speed with a sophisticated magnetic pulse detector, making hundreds of adjustments per second to ensure unwavering accuracy. The DP-80's control system was so advanced that it could maintain speed stability to within 0.002%, a figure that, for analog playback, was almost unimaginable. It was designed to withstand the rigors of continuous studio use, delivering rock-solid speed stability and powerful, authoritative sound. This was an example of precision through brute force engineering, an unwavering commitment to controlling every aspect of rotation. The DP-80 wasn't just a turntable, it was an edifice of audio engineering. Meanwhile, a classic from Switzerland continued to captivate audiophiles with its enduring charm and meticulous craftsmanship, the Thorens TD-125. First introduced in 1965, and produced for over 15 years, its longevity spoke volumes about its quality. Thorens had a long, storied history in precision mechanics, and the TD-125 was a culmination of that expertise. Like the Linn, it employed a suspended subchassis design, but with a different implementation. The TD-125 used a unique electronic speed control system, employing an AC synchronous motor that was incredibly stable, driven by an oscillator. This motor, combined with its heavy, precisely machined platter and finely tuned suspension, delivered a sound characterized by its solidity and musicality. The TD-125 was not just about speed accuracy, it was about the quality of that speed, the absence of flutter and wow that could introduce subtle pitch variations. Its robust construction and elegant design made it a benchmark for European precision, a turntable that, with proper care, would outlast decades of technological shifts. It represented the pinnacle of traditional Swiss engineering applied to audio, a legendary motor and bearing ensuring a smooth, unwavering ride for your precious vinyl. And finally, as the 1980s dawned, just as digital audio was beginning to cast its long shadow, a British company named Pink Triangle released a turntable that, in its obsessive pursuit of isolation, felt almost like a swan song for analog precision, the Pink Triangle Export. This was a radical design, pushing the boundaries of what was considered possible for vinyl playback. Like the Linn and Thorens, it was a suspended design, but with a twist. The subchassis was made of a lightweight, rigid material, a high-density, low-resonance composite, rather than metal. The motor was completely decoupled from the plinth and housed in its own separate enclosure, driven by a sophisticated electronic power supply that ensured perfect speed stability. But the most distinctive feature was its inverted main bearing. Instead of the spindle rotating within a fixed housing, the spindle was fixed to the subchassis, and the platter sat on a sleeve that rotated around the fixed spindle, with the bearing point at the top. This design, Pink Triangle argued, significantly reduced bearing noise and friction. The export was an obsessive quest for quiet, for an utter absence of mechanical interference. It was a turntable that demanded painstaking setup and an understanding of its unique principles, but when properly dialed in, it delivered a breathtakingly transparent and dynamic sound, revealing layers of detail few other turntables could match. These 6 turntables, in their varied approaches, all shared a common goal: to retrieve the music from the grooves with unprecedented accuracy. They represented a peak, a relentless pursuit of perfection in analog playback. And that's the irony, isn't it? Just as engineers pushed the boundaries of mechanical and electronic precision to their absolute limits, just as these calibration charts became the proof of their extraordinary fidelity, the compact disc arrived. With its promise of perfect sound forever, of digital ones and zeros, it rendered the intricate dance of these analog marvels almost irrelevant overnight. The painstaking setup, the delicate adjustments, the careful isolation, all seemed archaic in the face of instant, push-button perfection. The market shifted, tastes changed, and the golden age of the hyper-precise turntable, at least for the mainstream, began its slow fade. The true reason these elaborate designs, these temples of analog precision, began to decline wasn't a flaw in their engineering. It wasn't a sudden failure of the technology. The real problem was outside the listening room entirely. It was a cultural shift, a desire for convenience over ritual, for instant access over deliberate engagement. The precision was still there, the sound still glorious, but the world was moving on. Yet, for those of us who still cherish the tactile experience, who understand the magic of a spinning platter and a diamond tracing a microscopic path, these turntables remain monuments to an era when sound quality was an obsession, and every detail mattered. They teach us that sometimes, the pursuit of perfection, even if ultimately surpassed by a different technology, leaves behind a legacy of unparalleled craftsmanship and ingenuity. What happened to the companies that didn't adapt,